The von Neumann architecture was the first major proposed structure for a general-purpose computer. John von Neumann was a Hungarian-American mathematician and also a computer scientist. However, before describing the main components of von Neumann architecture, let us first define the term computer, as this will help us in discussing about von Neumann architecture in detail. This is the architecture proposed by von Neumann. We will discuss about it later on the video. In the Oxford Dictionary, computer is defined as an automatic electronic apparatus for making calculations or controlling operations that are expressible in numerical or logical terms. The definition clearly categorizes computer as an electronic apparatus, although the first computers were mechanical and electromechanical apparatuses. Another important aspect of the definition is the fact that the computer can perform only those operations, which can be expressed in logical or numerical terms. Some of the basic questions that arise from above definition are: how are the data processing and control operations performed by an electronic device like the computer? Well, electronic components are used for creating basic logic circuits that are used to perform calculations. However, for the present discussion, it would be sufficient to say that there must be a certain unit that will perform the task of data processing and control. What is the basic function performed by a computer? The basic function performed by a computer is the execution of the program. A program is a sequence of instructions, which supplies the information about an operation, which operates on data, to perform certain tasks such as finding a prime number. The computer controls the execution of the program. Since data is important for proper functioning of computers, we will look at what is data in computers. In computers, data is represented in binary form by using 0 and 1. These are called binary digits or bits. But the data which we deal with consists of numeric data and characters. Therefore, there has to be a mechanism for data representation. Old computers use 8 bits to represent a character. Now we use 32 bits and 64 bits. Now we will look at some more questions. First, how are the instructions supplied to the computer? Secondly, how are the instructions interpreted and executed? Let us answer the second question first. All computers have a unit that performs the arithmetic and logical functions. This unit is referred to as the arithmetic logic unit, or in short ALU. But how will the computer determine what operation is to be performed by ALU, or in other words, who will interpret the operation that is to be performed by ALU? This interpretation is done by the control unit of the computer. The control unit accepts the binary form of instruction and interprets the instruction to generate control signals. These control signals then direct the ALU to perform a specified arithmetic or logic function on the data. Therefore, by changing the control signal, the desired function can be performed on data. Or conversely, the operations that need to be performed on the data can be obtained by providing a set of control signals. Thus, for a new operation, one only needs to change the set of control signals. The arithmetic logic unit and the control unit together are termed as the central processing unit, or in short CPU. The CPU is the most important component of a computer's hardware. All these arithmetic and logical operations are performed in the CPU in special storage areas called registers. The size of the register is one of the important considerations in determining the processing capabilities of the CPU. Now we will answer the first question: how are the instructions supplied to the computer? The instructions and data to a computer are supplied by external environment. It implies that input devices are needed in the computer. The main responsibility of input devices will be to put the data in the form of signals that can be recognized by the system. Some examples of input devices are keyboard and mouse. Similarly, we need another component, which will report the results in proper format. This component is called output device. Some example of output devices are printer and monitor. These components together are referred to as input-output or I/O devices. In addition, to transfer the information, the computer system internally needs the system interconnections. At present we will not discuss about system interconnections in details, except the information that most common interconnection structure is the bus structure. Input devices can bring instructions or data only sequentially, however, a program may not be executed sequentially since it may consist of jump or looping or decision-making instructions. In addition, more than one data element may be required at a time. Therefore, a temporary storage area or a memory unit is needed. The memory unit stores all the information in a group of memory cells such as a group of 8 binary digits. These groups of memory cells or bits are called memory locations. The amount of information that can be held in the memory is known as memory capacity and it is measured in megabytes or gigabytes. Now let's look at the von Neumann architecture. It consists of things we already discussed such as input device, a CPU which contain control unit and arithmetic logic unit, memory unit, and output device. For transfer of information it also contain the system interconnections like bus. It was pointed out by von Neumann that the same memory can be used for storing data and instructions. In such a case the data can be treated as data on which processing can be performed, while instructions can be treated as data, which can be used for the generation of control signals. The von Neumann machine uses stored program concept, that is the program and data are stored in the same memory unit for execution. The computers prior to this idea used to store programs and data on separate memories. Entering and modifying these programs was very difficult as they were entered manually by setting switches. Plugging and unplugging of switches was also very difficult. This led to some costly mechanisms and costly computers. Execution of instructions in von Neumann machine is carried out in a sequential fashion, unless explicitly altered by the program itself, from one instruction to the next. This will allow us to pinpoint if there is an error in the program code. A von Neumann machine has only a single path between the main memory and control unit. This feature is called von Neumann bottleneck. Several other architectures have been suggested for modern computers but none of them was not as successful as von Neumann architecture. That's why even now we use it on our PC.